So to start, let's look at some code. I've been going through slides all last week, so let's get into the code and talk about what you're actually going to do for your projects. Because I would be very understandable if there is quite a bit of confusion right now about what you're actually supposed to do, even if the concepts in lecture are making a lot of sense. It's not super clear what you're supposed to do. So let's do that. So I'm going to start with Python. A lot of my lecture examples will be Python. Today I'll do Python and JavaScript. Those are by far the two most popular languages that students choose in this course. So I'm going to, at least the technology in this room is working today. My first lecture wouldn't talk to my laptop. So I'm going to cover those two languages. I said this last week, but I'll reiterate. I do recommend Python for the course. Eventually, I'll probably drop that recommendation. Eventually, I actually want to force Go on the whole course and have this just be a Go course. But it'll be a while before I make that transition, if ever. But right now, Python is the language that gives students the least amount of trouble. And it's the language that allows you to focus on the concepts of the course without the language itself getting in your way. JavaScript isn't bad. Go is good. Go, I think, realistically, I think the course should be in Go. Either Go or C, but I hate C. That would just be torture putting you through that. But Python lets you focus on the concepts of the course without getting bogged down with language-specific details. So I do think Python will be best for your education, at least at this moment, unless you do want to dive into Go. So with that said, here is a very basic Python server. The big thing that you want to start with, and if you ignore everything else I say and just get this one thing, use socket server and then look up a tutorial for socket server online if you don't like the way I'm going over it, which I don't know why you wouldn't, but definitely use socket server. If you're going online, if you want to use a different language, just start with, say you want to use Java. I wouldn't recommend it. I've never seen a student be really successful with Java in this course. Like, they can get through the homeworks, but they have a lot more trouble. But if you want to use Java, go to your favorite search engine, Java TCP socket server, and then a whole bunch of tutorials will come up, which will show you how to get started with this course, how to set up your TCP server, and then you're going to build your HTTP server on top of that. So socket server for Python, if you just go Python TCP socket server, one of the first tutorials that comes up imports socket, which is a lower level library than socket server, and shows you how to create a TCP socket server using the socket library. Socket server uses the socket library under the hood, but it adds a lot more quality of life features for you. Specifically concurrency, it handles concurrency for you very easily. If you use socket, you'll be fine until we need concurrency in homework 3. Once you get to that, things fall apart. Is it homework, or is it homework 4? Whenever we do WebSockets, I forget which one it is, 3 or 4. But once we get to that point, 3, it's 3. Once we get to that point, socket will completely fall apart, and you'll be regretting not setting everything up with socket server. Set up a socket server now, and then you won't even notice that you hit a road bump later on, because you'll just fly right over it. Yeah?
Is it necessary to set up the main function? I think I've gotten it working without.
It's not necessary to set up the main function.
Okay.
In Python. There are reasons to set up a main function in Python. You won't run into those reasons in this course. Very briefly, I mean, it's useful general knowledge. But I have a main function here. Not method, we're not in Scala. A main function. But if I didn't have this, if I didn't have main, when you run a Python script, it's just going to run any code that's not in any functions. So if I don't have any of this main stuff here, and I de-indent this code that's in my main function, everything works just the same. The reason to have a main function in Python is if you're running that module sometimes, but also sometimes importing the module. When you import a module, if you're not using a main method, your main method code is going to be executed, which if you're importing a module, probably isn't what you want. So when you do a main function, you're saying run this code when this script is executed, but not when it's imported. So that would be your reason to use a main function in Python. So if it's only meant to be executed, but not when imported, that's when you really want to do it, but it's just good habit to get in that rhythm so you don't run into that issue later on. Yeah. Mm-hmm. So in the homework, I always say use 8080 for your port. When we get to Docker and Docker Compose, you'll use 8080. This number isn't going to matter in your homework as long as Docker is pointing to whatever port you specify here. So in my Docker file, I'll say map port 8080 locally to port 8000 inside the container. But that's the next few lectures. We'll talk about that in more depth. So if I don't use 8080, that's why. Even though, you're using 8000 in lecture, but you say 8080 on the homework. That's the reason why, because when we go to Docker, I'll use 8080. And you can choose port numbers. You can choose whatever port number you want, within reason. But anyway, socket server is the main point here. So to create a socket server in Python, first we need to extend the base request handler class. Create a class. This is inheritance in Python if you've never seen this before. I'm creating a class named MyTCPHandler, which extends socket server from my library .base request handler. Or you can import base request handler from the library and then not have this socket server whatever syntax you want to use. But this is extending a class in Python. This class, this base request handler, has one method that we really want to implement, handle. This method is going to be called whenever a TCP connection is established. So whenever a client connects to our TCP socket server, handle is going to be called, and it's going to be an object which has all kinds of information about the connection. Yeah.
Is handle the one that breaks down the GET request into the relevant data?
It will when you code it. So what all handle does is say, hey, I got a TCP connection. Here's a reference to the TCP connection, which we'll call a TCP socket. Here's a reference to the TCP socket. Your code is going to go inside this handle method, and you're going to implement the HTTP stuff inside of it. So handle is going to handle the connections. I'm going to jump to the bottom and then go through the code that I have here in the handle method. Handle is going to be called whenever a connection is established. And to start your server, we're going to use this code. There's not much to explain here, I guess. But we're going to specify the host and port. Your host is going to be, in documentation you look up, it's probably going to say localhost instead of 0000 like I have here. Localhost doesn't play nice with Docker. You have to have 0000 to play nice with Docker. So if you just start with that, things are going to be fine for you. And then the port number. So we talked about port numbers a little bit with TCP and a little bit just a minute ago in this lecture. Port numbers are not magic. Of course, there's no magic. We're dispelling magic in this course about the internet and the web in general, or the web and the internet in general. Port number is just a number. It's just straight up just a number. So there are a few port numbers that are designated for special cases, like HTTP is defaults to port 80, HTTPS defaults to 443, and others, FTP to 20 and 21 for FTP and FTPS. Doesn't matter. But anyway, once we get into the higher number port numbers, those numbers aren't allocated for anything. So once we get up into the several thousands, especially like 8,000 where we are now, this is our playground as developers. We can choose whatever port number you want. I can use 8,000. I can use 312. The website runs on 8312, just because I like that naming convention. The 116 website runs on 8116, etc. You can choose whatever port you want here. I like to just stick with the 8000s is common for dev, but this is just a number. So I chose 8000 just because whatever. When you get to your homework, when we get to Docker, it'll have to be 8080 for the homework just so we can test easier, but the port's just a number. So when you create your server, you're going to specify the host and port. This is effectively localhost on port 8000, and give it your class, your MyTCP handler class. You're not creating an instance of the class, but you're given the entire class itself, so it knows what class to use whenever a connection is created. And then when a connection is created, a client connects to you, does the three-way handshake, which we don't have to care about in our code. But once the three-way handshake's over and done and there's a connection that's established and we're communicating over this TCP socket stream, the handle method is going to be called. And it's going to be called in a different instance of your class for each client, so you can maintain multiple clients simultaneously. One more thing to point out. In the documentation, if you just find whatever documentation online is out there, it'll probably just say TCP server without threading. If you add this one magical word, threading, right here, your TCP server will be multi-threaded. If you use socket server, it's that easy. You're multi-threaded, and you can handle, like I just said, multiple clients simultaneously on separate threads. If you don't use threading, you can't handle multiple clients simultaneously. And if you use sockets instead of socket server, it's quite a pain to handle multi-threading. And then finally, start the server. Create the server, start the server. So that's all boilerplate, importing it, creating your TCP handler, and the main method to get things started. So once we have a TCP connection, what do we do with this? And the answer is just, well, I'll save that for the slides, but just talking bytes to each other. So what we do in Python, some of the syntax, we're going to take the request and call this receive method with a number of bytes to receive. I meant to change this, actually. I'll change it right now. Oops, 2048. In very rare cases, having 1K as the buffer size caused issues for like one or two students last semester. So if you use my code, use 2K. We're going to receive information off of the TCP stream. This is going to get information, bytes, off of our TCP stream, and now we can start handling these bytes. Now, for our purposes, we expect these bytes to represent an HTTP request, and we're going to decode it, parse it as such. We're going to treat it as a string, parse all of our information there, figure out what's being requested, and then send back an appropriate response, just like we've been learning in lecture for the past week, or for the past 2 lectures at least. So receiving, this is going to give us a byte array with all the information of that request, which we'll assume is an HTTP request for this course. For what it's worth, we have access to the client ID. This won't be necessary until later in the class, but I wanted to leave this here. And when we get these bytes, we want to treat it as a string. So in any tutorials you look at, you're going to see this decode and encode all over the place. In the slides, I'll explain what that means. I'm going to decode this data and then see what it is. For this example, I'm just printing it to the screen just so I can see what was sent. And then I'm going to send something back over the TCP connection. I want to send something back to the client. I'm going to use this self.request.sendAll, which is going to send a byte array back to the client. I'm going to format it as an HTTP response, just like we saw in lecture. Actually, it's almost exactly what we saw in lecture, except I have this char set UTF-8, which we'll talk about today. And I'm giving it I have a string here, but I can only send bytes over the internet. So I got to slap this .encode at the end, which is going to convert my string into a byte array. Decode, bytes to a string, encode, string to bytes. Very important to have those two there. So let's run this thing. And I don't have it printing any nice messages, listening for connections on port 8000 usually. I don't have any of that on mine. I'm going to go to my browser. I'm going to go to localhost port 8000. Make a request. And then I want to go back to my code and see what's going on. So we're going to hit these 3 print lines first. And we're going to see the host and port number of who's sending me data, which we see we got a port number in the 60,000s that my browser used. We can talk about that if at some point. or right now. I do like talking about it. So HTTP works over port 80. You've probably heard that a lot. If not, you've heard it from me at least 3 times this semester. HTTP works over port 80, HTTPS over 443, but that's only for the server. So you have a server that's listening on those port numbers, but a client can connect on whatever port number they want. In this case, we got 60,789 is the port number that my browser used to create the other side of that TCP connection. Why not use port 80, though? If we used port 80, how are we going to have multiple connections simultaneously? If I got 20 tabs open and I want to be accessing 20 different pages and accessing different content simultaneously on all those pages, how does my operating system know when it gets information over ports 80 and 443, how does it know which tab to send that to? How does it know what process to send that to? The answer is we don't use port 80. We use these really high random numbers for ports so that the browser can have multiple TCP connections open for all the tabs and all the, whatever. Yeah.
So that's the host that's sending the request, right?
That's the client that's sending the request. So this is my browser. When I went to my browser and accessed this page, my browser created this HTTP request. It sent a TCP connection, did the 3-way handshake, chose port 6789, and connected to my TCP server, and then sent this information. When I called receive, I got 605 bytes, because for whatever reason I'm printing out the length of the data. And then I get this HTTP request. This is what my browser sent to my code.
No, what's the host, though?
The host is localhost. So localhost is kind of like the domain name for 127.0.0.1. That means that's localhost. It just means that this machine sent itself a message, because everything's just on my laptop on this example. And then it sent this HTTP request. We're going to assume it's an HTTP request in our code and decode it based on what we know HTTP is, but everything is what you would expect it to be. We have the request line according to the last few lectures. We have the request line. This is a request for, actually, I don't want to look at that one. It's a request for fav icon. This is the icon that's in the tab for the browser. If you get these requests, it's fine to, you should, according to the homework doc, respond with a 404. But let's look at the root request. So get the root homepage using HTTP 1.1. We have all kinds of headers. The browser's going to send all kinds of headers to us. The important ones that we've talked about are, we didn't talk about any of these, did we? Except host. We didn't really talk about any of those. But we have all the headers, and then we can respond. I'm responding with my HTTP response. The body of my response, making sure that the content length was right, making sure that the content type was right. And that's why in my browser, we were able to get hello in the browser. So that's my Hello World web app, web server. I can actually go to my browser. My browser is going to talk to my TCP server, which I'm building as an HTTP server, and actually get hello rendered in my browser, which is a good sign that I have everything coded the way that my browser expects. Yeah.
What is the client network status every single time the client in the browser refreshes the result?
What?
If you refresh the browser,
Mm-hmm.
the client network changes. Why is that?
So we can have multiple connections. So this client ID, the port number, so the port number can be different every time. And since this connection, it already did its thing, a request and a response, that connection is going to be closed. And however the browser is coded depends on what the next port number is going to be. So we got 60, 787, 789, 59, 33, 44. It's going to be different each time, or it could be the same, just depending on how the browser is coded, how the browser is managing the port numbers that it uses. But it can't use a port that's already in use, so the connections might still be open for the other ones, even though our server's done. Our servers are only going to send one HTTP response per connection. But the browser might still be waiting for something more on that connection, depending on how the browser works. but it's up to the browser how to code that. If I used Chrome on the same example, I'll get different port numbers. All right, and I promised you a JavaScript example. So that should get you started, by the way. That should get you started on the homework. You should be able to code that today and get the first task of the homework done today with responding with text, a 304 and a 40, or a 301 and a 404 response codes, like we talked about last time. You can code all that up with this information. Yes? When I went to the address bar, and I typed localhost :8000. So I'm saying send a message to this computer's port 8000. And when I hit enter, what a browser is going to do when you type in a URL is it's going to send a GET request, an HTTP GET request to that host and port. And I didn't give it any path, like I could say /hello, and then it'll send a request for the path /hello. I didn't type anything there, so it just sent a request for the root path /. Right now I won't get anything because I shut down my server. So let's do the same thing. I'll go a little bit quicker in JavaScript. Fewer students chose JavaScript before I started pushing Python so hard, and now that I push Python so hard, very few choose it. But I do want to show it. The library here is net, require net. Bless you. Require net, and then net has create server, which is going to take a callback, which takes a socket. Socket is going to be, and this is pretty much all of JavaScript, but especially this library, is going to use an event-based architecture. So on data means whenever data is received from any client, from any TCP connection, call this callback, which is first-order functions, all 116 stuff, all that event-based architecture and first-order functions, functional program. It's using all those concepts. When data is received, call this function with that data. And that data is going to be as an array of bytes. And we can access the same information. We have the socket, which gives us the remote address and port, which will be localhost and some random port in our case. And data is going to be the byte array. Instead of decode, JavaScript is going to give us toString. Convert it to a string, and then we can deal with it as a string instead of as a byte array. How is Node different from JavaScript? They're the same, I guess. Node is the engine that runs JavaScript server side, or just generally on a machine. Whereas JavaScript was initially built just to run inside a browser, Node lets us run it anywhere. So Node kind of is JavaScript. Node is going to execute your JavaScript code. So toString, and then socket.write to send information over the TCP connection. And then put .listen at the end of your create server, the server that's created, or store this in a variable and call listen later. But .listen, give it the host and port. Run this. Then I type JavaScript almost. Node server 1. And I'm going to send a response with the content hello and then some non-ASCII characters. That'll be important. That'll just be important. I'm going to go to my site. I'm going to see that I got everything working the right way. And one thing that I recommend here, a few things here. One thing that I recommend is embracing code modularity. We've been talking about this stuff since 1.15, but write functions and separate your code out. Even write separate classes or separate modules and get your code separated and organized in a nice way instead of having one giant, like this socket.onData, one giant chunk of code there, or in Python, one handle method with absolutely everything for all 4 homeworks. It gets to be cumbersome. It's a huge mess. A lot of you will end up doing that. You know, it's fine, but I can't help you, and the TAs can't help you as much in office hours because we can't read your code. And usually when we do find the errors, when I find an error with a student like that in office hours, it's usually because their code was so disorganized, they just made a silly mistake that they knew how to code it, but the code was just such a mess they couldn't see what was going on. I strongly encourage you to do this. So right here, I'm using a build response method that's taking the response code, the MIME type, and the content type, and the actual content, and then building the response and returning that response. And then I can send it over the socket. So I strongly recommend starting to do things like that. Write your generic methods. Write a method or a function that's going to parse your headers for you and return them all in a key value store. Write a function that's going to build your responses like this. Write a function or even a class that's going to parse your requests and put all the information where you want it. Strongly recommended. And one thing for the content type here, I added this char set UTF-8. This is important. If I mess this up, restart my server, and go back to the browser, my UTF-8 code characters aren't going to render properly. So if you see something like this, double check your char set to make sure you have UTF-8. Yeah.
What are those symbols? Is that just like random binary?
This is just decoding errors. It's trying to decode UTF-8 encoded characters using a different encoding, whatever the browser default is, which for some reason isn't UTF-8, which frustrates me, but whatever. It is what it is. But whatever encoding my browser is using, when I don't specify UTF-8, it's whatever those bytes decode to. All right, any questions about that before we jump into slides? And notice all I did was change the dash to an underscore. This has to be exactly UTF-8, all lowercase, dash 8. It has to be char set equals. That has to be exact. I had that question in office hours a lot last semester, so I want to squash that early if I can. Yeah.
So I want to ask about also when we start with our small server and run the server again, and always says the address already used.
Mm-hmm.
So my server is grab the service that you process code and do it and run the code again. So do you have any more convenience?
And this will come up in certain situations. What you'll see is you're running your server, you're testing, you change the code, and you restart your server, and it says address already in use. What that means is that the port number that you specified is already being used by another process, which in almost every circumstance is going to be your process. It's going to be your old server that just doesn't want to die. So my easiest fix to that is just change the port number. And you can cycle through like 3 port numbers. By the time you get to 8001, 8002, by the time you get there, 8000, that process will finally be dead and release that port. And you can go back to 8000, just cycle through the same 3. That's my quick and dirty hack for that. Because sometimes, I forget exactly when that scenario comes up, but there's certain scenarios where it just doesn't want to die properly. Bless you. Did I already download this? I think I did. Well. Okay, so I mentioned some things when I was in the code there that you might have heard for the first time, so let's talk about those things. UTF-8, MIME types, encodings. Let's talk about what this stuff is. Oh, and one thing I forgot with the JavaScript, for those of you who are going to use that, JavaScript/Node, I gave it just a straight-up string when I sent the thing. JavaScript, the library, the net library, will convert your strings to byte arrays for you, for what it's worth. You also saw buffer.from. Buffer.from is going to explicitly convert a string into a byte array for you. So you saw when I need to concatenate 2 byte arrays, I had that buffer.concat and then buffer.from and concatenated 2 byte arrays. It's one of the reasons why Python is a little bit easier. You just add 2 byte arrays together using plus, just like string concatenation. So it's one of the things that makes Python just a little bit easier in the course. but I forgot I didn't explain that in the code. Anyway, encodings. Let's do this. So the internet is a bunch of wires. We know this. We've talked about this, which means all you can send is either high or low voltage, or light and dark, or over the air. I shouldn't even said that because I don't know. I don't have a brief way to say how that works. But over the air, having different wavelengths, not different wavelengths, but different peaks and valleys on your waves. And how do we use this to build the internet? It's just ones and zeros. What are we doing here? What do we do? The answer is going to be MIME types and encodings. So that's what we want to talk about here. Because when in the code that we just saw, when we read from that TCP stream, it's just a byte array. A byte array is strictly ones and zeros, just chunked into chunks of 8, and then thrown in an array. We have to make sense of that information somehow. How do we do that? So this is where the content type headers come into play. When we send a response, to make sure that the browser can read the response that we're sending, we have to make sure that that content type is going to say, hey, this is what the body is. This is what that content actually represents. I know it's just ones and zeros, but this is what's up. The content type is going to tell the browser how to interpret those ones and zeros. And it's going to store what we call the MIME type of the data, which is something that was stolen from old email. I saw extensions instead of extensions, but an old email protocol that was good enough that it outgrew email and is now used for HTTP. It's pretty fundamental to HTTP now. A MIME type is two separate parts, a type and a subtype separated by a slash. We've seen text slash plain. We've seen that already. We're going to start seeing other types. This is where we're getting into Objective 2. Right? Yeah, Objective 2, serving your HTML, your CSS, your JavaScript. This is how we're going to serve those files, is by specifying our MIME type, opening the file, and then putting the bytes of that file into the response. Common types that we'll see, text, image, video. And common subtypes, text/plain we've seen, text/HTML if you're sending HTML, text/CSS if you're sending CSS, text/JavaScript if you're sending JavaScript. Those three are pretty straightforward. And then for images, after the slash is going to be the type of that image. Is it a PNG? Is it a JPEG? Let the browser know through your MIME type. If it's a video, if it's an MP4, what type of video is it? This is how we're going to tell the browser how to read that information. It's just ones and zeros, but hey, those ones and zeros are encoded using the PNG format, protocol? I don't even know what to call it. I'm tempted to say file format, but it's really outgrown files. If you want to add extra information to your MIME type, you can add key value pairs after the to your content type. After your MIME type, you can add key value pairs to your content type after a colon, or separated by colons. And this is the syntax for that. You saw it in the code. But one thing that we'll need to do is specify a char set of UTF-8 for certain things, because I wrote the homework this way that you have to do this, or else the browser will have decoding errors and you'll get the garbage characters that we saw in the browser just now. So if you want to add extra directives, which in this case, specifying that the encoding protocol was UTF-8, then we do that with this syntax. Semicolon, char set equals UTF-8-8, and like you saw, this has to be exact. If this dash is an underscore, the dash isn't there, it's a really frustrating office hours visit for the student, not for me. It's an easy day for me, that you have an underscore instead of a dash. But it's a frustrating thing for you if you have that. Make sure you double check this before coming, because if you bash your head against something for hours and you're frustrated, you come to office hour after waiting in line for a while, you go into office hours and say, oh man, what is this? I'm like, you need a dash there. It's really frustrating for you, and I completely understand why. Very frustrating visit. So double check that, because we do get that in office hours quite often. Hopefully less this semester, because I'm emphasizing it at least twice in this lecture. But this tells the browser that the content is encoded using UTF-8. Browsers, if you don't set your MIME type, if you don't even have a content type header, most of the time your browser's going to just figure it out for you. This is what's called content type sniffing or MIME sniffing. The browser is going to look at the content and just try to figure out what it is. It's going to be like, well, this looks like CSS, so I assume that they meant that CSS was the MIME type. This is a convenience that browsers do for us, but it's often not what we want. And we can shut this off with an extra header, which is required in the homework, X content type options, : no sniff. If you set the no sniff header, this says, hey, browser, don't be a bro, don't help me out. I set the content type, and that's the type that I meant. I said it, I meant it, it's right. If something's off with it, just don't render the content. Don't try to help me out and render this content using your MIME type sniffing. Just turn that off. And this is best practice. This is very typical to turn this off. We don't want browsers doing this for us. But why? It sounds super helpful. Reason is there's a big security concern here. What if you have a website that's set up to accept image uploads, which you'll do for homework 2, where users can upload images to your site, and those images are displayed to every user who goes to your site. Everybody can see images. We've done this online all the time. We expect a lot of apps that we use to have this feature. If you go to any social media, like this is what happens all the time. This is a regular feature that you see all the time. But what if somebody gets smart and says, well, instead of uploading an image, I'm going to upload some JavaScript code that steals all your information, steals your cookies and login information and transfers everything in your bank account to my bank account. I'm going to write my JavaScript to do all that. And you send this image to what you think is an image to all your users. You have the MIME type set as image/PNG, and the browser says, nah, this is JavaScript, and runs it as JavaScript for everybody. No, I said it's a PNG, treat it as a PNG. If anything's up, just don't handle this data because it's a PNG. Turn off type sniffing and just get your MIME types right. This is also something that can cause issues across browsers. If you're relying, say you're testing only in Chrome and you're relying on the no sniff because you have the wrong MIME type, but you're just not aware that you didn't have the right MIME type. Everything works great on Chrome, and then Firefox sniffs the MIME type a little bit different, and your site doesn't work on Firefox. You go live, and all your Firefox users say your site's broken, and just generally bad practice anyway to not turn off no sniff. All right, let's get to some text. We got a lot to talk about here. So we're only sending ones and zeros. How do we send text? I'm trying to go through this fairly quick. I assume you've probably all seen ASCII at some point, but if not, I want to give a brief overview of it. ASCII is going to be a way to use those bytes to encode characters, and ASCII is going to be a 7-bit protocol. So we have 7 bits to represent a character, and we have a mapping from each value that can be represented in 7 bits to a specific character. So we have, this is the entirety of ASCII, all 127 values, everything we can 128 values because 0 is included, everything we can represent using 7 bits. These are the characters, these are only characters available to us in ASCII. 220 flashbacks, good. Does that mean he goes over ASCII? Good, I don't have to. The one thing I want to say about ASCII is your headers in HTTP, ASCII only. They have to be ASCII characters. This is part of HTTP, have to be ASCII only. It's the only encoding we can use for HTTP headers. Can't have anything that's a non-ASCII character in an HTTP header. Requests or responses. So if I want to encode hello, this is programming language specific. The string hello, a Python string, is different than a JavaScript string, is different than a Java string, is different than a Scala string, etc. The way that they're actually represented in those languages are all different. They have their objects in some languages with different methods, and C doesn't even have strings. Like, it's different in every programming language. So we want to encode that. So in your Python code, when you're doing .encode, you're going to take that Python-specific string class or string object and convert it to a byte array, which is just going to be the bytes representing that string. And then those bytes, this is in hex, but those bytes are actually zeros and ones, of course, if you expand the hex. And that's what we send over the internet. To send the string hello over the internet, those are the ones and zeros that get fired over the wire or over the fiber or over the Wi-Fi. I already said that. Which is fine, but there's only 128 characters that we can encode with ASCII. That's very limiting. It's okay for English, it's fine. But what if you have a language that doesn't use our 26-character alphabet, which is many languages out there, or languages that need, I blanked on them, but the symbols over your characters, I can't even think of what they're called right now. Umlauts, aren't they? But if you have the special symbols and stuff, you can't do that with ASCII. It just doesn't do it. So we need more power, and in come UTF-8. So UTF-8 is a different standard, obviously, than ASCII. It's going to be a variable byte protocol, which uses up to 4 bytes to represent a single character. And there are 4 different cases here. One, if the first bit of a character is a 0, then the next 7 bits are exactly the ASCII representation of a character. There's one really powerful part about UTF-8 is that it's easy to expand from ASCII to UTF-8 because ASCII is a subset of UTF-8. All ASCII is valid UTF-8. Every ASCII string is a valid UTF-8 string. So you can just immediately expand that. Yeah.
If it's still using ASCII and UTF-8, then why doesn't it interpret like a Mandarin symbol as 4 different English letters?
So it would if we take a UTF-8 string and say decode this as ASCII, then it would try to decode it as 4 separate characters. If you have an ASCII string, then every character is a single byte, and they are all valid single byte UTF-8 characters. So you can go from ASCII to UTF-8, but you can't go backwards unless you just happen to have all ASCII characters. Yeah?
Oh, so does it use the number of ones in the first byte to determine how many
Yep.
bytes after that is the same character?
Yep, you read my next slide to me. Nice. So if the first bit is not a 0, then that byte is going to start with a number of ones equal to the number of bytes that represent that character. So 110 means the rest of the bits of this byte and also the next byte are part of the same character. If it's 11110, that means the rest of the bits in this byte and the next 3 bytes are all part of this same character, and all the continuation bytes start with 10. So with this structure, this significantly decreases the number of decoding errors, ideally to 0, unless you have actual errors, bits flipped in the thing, in the transmission. But this gives us a few characteristics. No character is a subsequence of any other character, which is a nice thing to help with decoding. And forgot what else I wanted. Prevents decoding errors. And you can detect errors pretty easily. A lot of times, if a bit is flipped, you'll get a decoding error and at least be able to know that something went wrong. But this is how we specify how to do a multi-byte protocol. Because how do you know if a character is 1, 2, 3, or 4 bytes? The number of ones in the leading byte. So when we send these strings over the internet, we need it all ones and zeros. We take our language-specific string, encode it using UTF-8, and then send that string over the internet. In your Python code, you're literally going to type .encode. That's going to take your string and encode it using that UTF-8 encoding that we just saw. When you receive bytes, you're just getting ones and zeros. You're getting a byte array, at least in Python and JavaScript. You're getting a byte array, and you need to decode those bytes using the proper encoding. In Python, you'll literally type .decode to decode those bytes into a Python string. Python and JavaScript will default to UTF-8, so you don't have to specify that you want to use UTF-8, but you can specify the encoding if you want. But it's not necessary for our purposes, at least. Yeah. You could, I don't know the syntax off the top of my head, but when you encode and decode, I think it's encoding equals ASCII. Yeah, it's, and I have an example of that I might be able to show at some point, but I'm up against it today, 4 minutes. The content length, it's very important that your content length is the number of bytes in the body of your response, not the number of characters. So if you have non-ASCII characters in your string that you're sending as a response, do not take the content length as the length of that string. It must be the number of bytes. So you want to encode into UTF-8 and then take the length. Don't take the length of the string. Take the length of the byte array after encoding using UTF-8. Okay. 3 slides, and I got to get through these. So when we send images, when you get to task 3, you have to send an image as a response. How do we send this? It's not text. That's the most important thing about this. It's not text. We cannot take the bytes representing our image. So you'll read your image file, you'll read it as bytes, and you'll have a byte array with all the bytes of your image. That is not text. It's not encoded using UTF-8. Which means your bytes aren't going to follow the UTF-8 encoding. It's not going to have a 0 and then some values, and then like a 1, 1, 0, and then the next byte might not start with 1, 0. Like, it's not going to follow that protocol. It's not going to do it. So your image is not a string, and you cannot convert it to a string because you will get UTF-8 encoding errors. It's not a string. And the important thing with files when you're doing Objective 3 is don't overthink it. It's already in bytes. When you create your text responses, like your HTML or CSS or just plain text, when you create those responses, you have to do extra work to convert your string into a byte array to be able to send it over the internet as 1s and 0s. Your image is already a byte array. When you're reading the file, make sure you read it in binary mode. Make sure you read it as a byte array so your language isn't automatically converting it to a string for you. But it's already bytes. Like, a file is just a bunch of bytes. Just read the bytes and send them. That's it. Don't overthink the file, sending files over the internet. But never, it's important to never, ever treat your file as a string, ever. You can't, or your, sorry, file, image as a string, image specifically. If your file is text, then it's fine. But don't treat your image as a string. It will not decode properly. You will lose data. If you take an image and you encode it using UTF-8 and then decode it immediately, you won't get back to the original image. It will corrupt the data. Things won't work. Can't treat an image as a string. And again, don't overthink it. Image.png. All right. Whoa, that's not the lecture question. Okay. And then as always, once you do the lecture question, you're welcome to leave.